Here we're talking about inverses and domain restrictions to make it invertible. A couple of things that you need to know for this question. Invertible means that the inverse of a function would also be a function. So if you think about this is a parabola here, and what I know about graphing, right? It's got a k value of -7, so it's something like this. If I were to take the inverse of this function, what I would get here is something that looks like something like this. And this is not a function because it doesn't pass the vertical line test. It has two outputs for multiple inputs and so on. So basically, this first part here is saying that this is not invertible. And what we need to do is state the domain of our original function here to make it so. What that means is that I'm really going to take just 1/2 of my function when I take the inverse. So I'm going to take the right side here saying that my domain is just all values of x that are greater than or equal to 0. So that's my domain restriction so that when I invert this graph, or I take the inverse, it will still be a function. Okay, now that all that is said, I'm going to write the formula for the inverse and then verify here in a second. So first thing I got to do is switch x and y, and now I'm going to solve. So add 7. Then I am going to take the square root of both sides. So I get the square root of x plus 7. So that there is my inverse. Now I'm going to take my inverse and I'm going to plug it back into my original equation. So I'm going to take f of -1. The way that looks is I'm going to rewrite f of x here. I'll do it in purple. But anywhere that I see x, I'm instead going to plug in the inverse. So square root of x plus 7. And then don't forget this -7 on the outside. Now I want to simplify. So because I'm taking the square root and then squaring that, these things actually cancel out. I'm left with just x plus 7 minus 7, and then 7 minus 7 is 0, so I get back to x. That verifies through composition because remember, what happens with the inverse is that, like, if I originally plug in x and I do a bunch of math to it, the inverse would be undoing all of that math. So I should get right back to where I started, which is x.